Hello everybody, what's up? It's Papa Bale. How's it going? All right. Hello, hello. Let's just put that in there. How's it going, everybody? Welcome. This is a pulse motor with the electromagnetic coils on the rotor and the permanent mags on the stator. Hello, hello. That is awesome. That's one coil for the drive. It's actually just 200 turns of 20 gauge for the drive. And the rest of this, well, you got a 28 gauge trigger strand, and then the rest of it's for the pickup. These are the other three are pickup coils at 30 gauge. It's got an on-off switch, so right now it's off. And when it's spinning in the off position, you gather from the pickup coils. Yeah, that'd be cool. All right, so I got some styling headgear for my pulse motor. Let's start with the half Utron or the comb. Actually, let's turn that on first. I'm gonna put this up in the tripod. I don't have a really good mechanism for stopping it right now. I didn't get a reading. That sucks. This is starting to fly out. Might have to glue it in. And then I got a pyramid one. This one looks a little dangerous, but it fits on the same way. Pretty cool, man. I think that's neat. But I think I am going to put this in there somehow. I don't know where to do it though. It's like, oh, right on top of it. Hello, hello. This is like the 8th time I've rebuilt this thing, and I think this is a good build. It's 3-to-1 pickup coil to drive coil with 1 trigger strand. There's only 200 turns of a drive on this thing. And all the rest of it gets collected in this cap bank. The battery gets collected in this cap bank. So there's a battery in here too. And it's all connected to this cap bank, and then it gets used through the cap bank. So will it, and forever isn't the goal. It's never been the goal. You know, it's just, and I do know that it works because I tried it without the battery and just the cap bank with the 3-to-1, and it spins a lot longer when it's on than when it's off. So that's a sign right there. It doesn't go forever, but it's a lot smoother in the rotation. Because what I mean by smooth, see how it's a little choppy, and that's because the magnets are the batteries are magnetized, you know. So if there's no aid going into this, it stops really quickly. But if there is aid, it'll continue to run even when you spin it really fast. It'll stop really quickly because of the magnetism. So, you know, it's just common sense in my mind. You know, that's how I knew it was working. Because you really can't tell. You really can't tell because you're always depleting. You can't tell whether or not it's working. And it is working, it's just not strong enough. I don't think anything will ever be strong enough. I could hook 9 coils, in my opinion, of the same size up to this thing, and I wouldn't come out ahead. As a matter of fact, I don't even know if the rotor would spin. So you got one drive coil right here. It's got 20 and 28 bifilar. It's 200 turns. And then these other pickup coils are 30 gauge, and they're 2,222 turns apiece. All these coils weigh 5 ounces. So altogether, you're a little bit over a pound. You're 4 ounces over a pound, which is a pound and a quarter. Where is the mercury? I don't have a license to work with mercury. I don't know if you need one, but you should. That is powerful, man. See, the only downside with this build is that I'm going to have to recharge the battery eventually. But I've made it easy for myself to do so, so I'm not really that worried about it. Could be. I don't know how to make a time machine. You tell me, bruh. I wish I could tell you. Don't want to let that one get going too fast. These edges are really sharp, and I gotta stop it by hand. So, hey, what's up, society? How's it going? How are things? But the Utron part, I can do all day. Let me just make sure we're on. We are on. Let's do this. That's about 550 RPMs. Heck yeah, man. So I bet you if I let this thing go, it would shake right off the table. There's got to be a weight discrepancy in here somewhere. I don't know exactly where it is though, because you got two batteries to level off on 180s, and then you got this cap bank, but it doesn't weigh anything, you know. But it might be enough to offset it. I want to get an aerial of this thing. So it's 3-to-1, one drive coil, 3 pickup coils. That's going to make a callus. What up, though? How's it going, everybody? Hanging in there. All right, so, I've been working with super caps over on the other motor, so we might want to check that out in a little bit. I made it so the battery like barely depletes at all, because all it does is feed the cap bank, and everything else is feeding the cap bank as well. So it's pretty neat. It does deplete though, but it's all right. Oh yeah. This is complicated. I like this one. I just gotta make it so it fits. Yeah. Hey man, if there's a sign up to go to space, I'll be one of the first ones on the list. We're going to Mars, and it's gonna be an excursion. You know, it's gonna be freaking for fun. There's actually quite a bit of torque for one coil, dude. It's awesome. All right, let me turn that off real quick. I do want to check this out over here, so I'm gonna move us over here. There is no overheating currently. I check it. Like every time, like I leave it, I should check it now. Well, I have a toggle switch. It's a little bit more heat than I'm used to, but it's still cold. I would say it's cold. You know, basically, it's about the same temperature as all the other coils. And I get to cut the power off, so I mean it will, maybe it will overheat, but it hasn't so far. All right, so this circuit may be a little bit hard to explain, but I'll get it out there. All right, so let me just turn it on. I'll get you off the tripod so you can see everything. All right, so we got our big wheel here, 5 neodymium magnets that are 40 millimeters by 20 millimeters squared. They're square magnets. We got our 2 coils underneath. We got a drive coil that's the same coil as that I'm using on the other motor. And then we got a pickup coil, which is 32 gauge. I'm willing to bet they're both probably around 5 ounces. That's more than 3,000 turns of 32, but it's like 5 ounces. All right, so the pickup coil is hooked up to the cap bank. Okay, so when it spins, it dumps into the cap bank. It goes through some rectifiers right there. And then let's go over to the other side so I can show you the rest of it. And is it a cure-all or whatever? No, it's not. It works well though. Okay, so now we got the Bedini SSG, and it's dumping itself into the cap bank as well. And we got the battery, and the battery is hooked parallel to the cap bank. So when the cap bank depletes, you take from the battery. And you're always taking from the battery, but the rate at what you take from the battery changes depending on how much energy you put in the cap bank. So we're going to mark it at 12.09 on the battery, and we'll check on it a little bit. But the cap bank is then, let me think, all the positive and negative connections are made to both the to the cap bank. So the Bedini SSG goes to the cap bank, and the coils, the pickup coil goes to the cap bank, and those are my two charging mechanisms. And then the battery itself goes to the cap bank, and then you draw from the cap bank with this cap bank. Okay, so you got the big cap bank, which is hooked to the battery, hooked to this cap bank, and voila. We're running the whole thing off of this one right here. So this is power plug number 1, and this is ground right here. Oh, this one isn't designed to go fast. It doesn't, excuse me, sorry, it doesn't go fast. But in order to make it go really, really fast, all you got to do is take the load off of it, which is, of course, in this instance, itself. Okay, that's how you make it go faster. You take the load off of it. But as you can see, the point will become very clear. Just one, Mighty Mouse. So I'm going to let this run. I'm going to go back over here. It's a little dark over here, but yeah, it's cool. And then I could, here, what I'm going to do. You hear all that flapping? That was my thumb, like, stuck in there. This thing is amazing. All right, I'm gonna try and make it go faster. You're right, man. This isn't fast enough. But maybe. Hold on. Let me try this. Nope. And if I change any of the connections, it won't have the longevity that it does right now. But here, let me try removing this coil all the way like that. I can already feel it going faster. And there really shouldn't be any like problem there because there are rectifiers on the coil, so. Sorry, did somebody ask me to explain something? Yeah, okay. No, it's not perpetual energy, it's just efficient. That's our energy right there. It's still at 12.09. So, yeah, I'll explain it again. What it is, that is totally up to you, man. I'm just going to explain the connections here, and you can decide for yourself what it does. It's not supposed to last forever, but it's lasting a pretty long time right now. All right, so you got this pickup coil, and you got your drive coil underneath the motor. The pickup coil is just collecting magnetic energy off of the coil from the spin. You know, that's what it does. That apparatus, that pickup coil, is connected to the cap bank. Okay, and then let's see here. There's a lot of three-way connections on this thing. So the cap bank is connected positive and negatively to the other cap bank. It's connected positive and negatively to the battery. You got your SSG circuit here. And there's your extension. Your charge capabilities are off this clip. It's connected to the collector. And it's all connected to the cap bank. All of the charging mechanisms are connected to the cap bank. The battery itself is connected to the cap bank. And so as long as there's energy in the cap bank, the battery won't, you know, uh, be drawn from. But it started at 12.11, so I know that it draws from the battery. And cap banks, when it's doing a 20 gauge coil that's only 200 turns, like 5 ounces of copper, cap banks deplete rapidly. They do. No, I'm not trying to do anything like that, man. I'm not the G, okay? I'm not God. I'm not trying to create, okay? What I did make is this, I would call this a Bedini style motor. No. No, I'm not going to do any of that, dude. I mean, I've got copper lying around here, but I'm not going to roll any more coils right now. And there's only position underneath this thing for 2 coils. So that's how it's going to be. Now, what I did here, I replicated on that motor over there. And there are 3 in series over here. 3 coils in series over here. So you're getting that much more energy through this one. And look at the magnets that we got here. These are neodymium N54s. At least that's what the jokes are. You know, they're N54s because they're so powerful. You can call it whatever you want. How's it going, boss? This can do a lot of things, man. This can spool up stuff. This thing right here, you turn this on and you put a spool on top of it, and you can spool thread really, really fast, man. Whatever you want, wire, thread, and it's fast. It's not a record player, man. It's fast. Look at that. So cool. That's probably the longest time it's been on a single hundredth for a while, like since I put it together. Oh, hold on a second. Yeah, not, none of that. None of that, man. Oh, the flux capacitor. Here's 3 pieces of it right here. They're wedge coils, 120s. So at 120 degrees, you put one of these coils. Yeah, I don't know about all that, but I know that this and my documented history of it since I started working on it. So, yeah. It's phenomenally how awesome it picks up, man. There's lots of torque here. See it just push my hand around? I mean, Jesus, it's not that heavy. Yeah, I like that one too, man. And it's an awesome build. Could you stop talking in pseudo religious yap shap mother? Please, dude. Quit talking about sheeps and lambs and wolves and crap. Just be normal. Cows. I mean, what does that even have to do with any of this? Yeah, it's true, but I mean, you must have a broken life. I don't know. I haven't checked it. Let's see if it lifts. It's got 4 ends, so no, it's not the flux capacitor. I think members of the Illuminati, quote unquote, would be a lot cleaner. Battery's right there. There's 2 of them in there. Boy! No. I'll probably have to charge the battery tonight, but I love this thing, man. I put it together 5 different ways, and then I finally did a trigger strand, and I lined the magnets up just enough. So if I lined them up better, they'd go a lot faster. But see, they're a little bit off, a little low. They're a little low, but that's okay. I think it's great. Thanks, man. Appreciate that. Yeah, no, I think about it all the time, man. That's why I double down on the glue. Thank you, society. Appreciate you. I've had magnets fly off on me, and other people had the same experience. It's PTSD after that around magnets for a little bit. Dark. What are you talking about, bro? And computer fists. What? What? Why not? That's my answer for you. Um. Heck yeah, dude. You can attach, fins or blades, or if you didn't have to stop it like I do right now, and you had it like on a switching mechanism, like in a cockpit or something, you could hook up stuff to that would make it fly. Should I restart this? I should restart this. No, they do not. No. Oh yeah, Radio Shack. My brother used to work at Radio Shack. This is 3D printed though. This one over here and that one over there. It's all 3D printed, except for the shafts and the bearings and all the electronics. For those wise people out there. You see that, man? This thing was like trying to take my thumb off. That's some torque right there, man. This thing is light. This thing is not heavy. I implore and I encourage anybody who wants to build one to build one. You got any ideas, man? Go for it. I encourage it. But I mean, this isn't wartime. This isn't a weapon. None of this is a weapon. Even if it can be weaponized, it's not a weapon. And that's all I'm going to say about it. Anybody who mentions, even, explosives, I'm going to ban you. The idea of this one over here is not to generate electricity. The only electricity that it generates is for itself. There's no way, except for a commutator, to connect this to anything except itself. And I don't have a commutator hooked up for it. Yeah, micro center. That's BS, son. Of course they can have fun. I have not drawn a diagram of this. But I can. It's really easy. I mean, it is so simplistic that I could make one really quick. Yeah, hell yeah. Junkyard magnets are extremely awesome. Very powerful. I didn't say no way. I said you have to use a commutator. Or you have to do it wirelessly. One of the two. Even the wirelessly, you have to be within range, you know? So I'm not saying you can't. I'm just saying that I can't right now, and I'm not even worried about it, like right now at all. Mm. Oh, I see where I messed up. There it is. All right. This is a Bedini SSG. With a few minor adjustments. Damn. Yep. That is the one thing that I forgot to do. Oh. Ah. Yes. There's a way we can get more speed. I just need to focus. Dang. I don't know. Hmm. it's not going to work the way I wanted it to. That's okay. I'm 100% cool with that. I don't know how I had it hooked up though. That's what's bugging me. So I'll just run it the way I had it before. It was weird. That is weird. Cap bank is low now. I got an idea. Huh. Don't know if it'll work though. Yeah, now we're using the battery. That's not exactly what I wanted to do, but it works. Alright. Yes. Yeah, I'm going to take it apart. I'm going to show you exactly how I put it together. This might take a minute, but you all deserve a proper explanation. We might put it together slightly differently. All right, we're almost there, kind of. So if that's not blown, that's our transistor. It is it's one of the MJL 21 something 4G. Those ones. Yeah. So we're going to do emitter to base with a Zener. We've got a Zener for the emitter to base. We're going to clip that right to the transistor. Alright, a Zener is one of these bad boys right here. Okay, now we're going to do our neon light. And that's going to go collector, which is the center pin, to emitter across. So collector to emitter. We've got a neon light in between them now. All right. Right. We're going to do the trigger strand now. We got a 100 ohm resistor between the trigger strand and the transistor's base. Okay, so we're doing positive end of the strand. Positive end is where you started wrapping the coil. That's your positive end. If you wrap them on your own. If not, then it's probably the red lead or whatever. Alright, so we're now connected to the base. Now we ground the trigger strand to the emitter. So you take the other end of the trigger strand where you ended the coil, and you connect that somewhere to your emitter. See, I have these little extenders. They're kind of like little breadboards, kind of. So now you have two things connected to your emitter. One thing connected to your collector, and two things connected to your base. Well, here, let me try this again. You got two on your base, one on your collector, and three on your emitter. Dang. Alright. Yeah, some of these components are frying on me. Then you get it all connected and you got a fried component. Alright, so we want to go through the coil first. Let's try just start hooking it up to the power supply to begin with. So it goes into the coil, the positive side of your coil where you started winding. And then we got to ground the coil or connect the coil to the collector of the transistor. So the end of your coil, or the negative part of your coil, goes to the collector. And then if this transistor is a good transistor, this should work after I connect we're going to connect that down there. Oh, dude, not cool. Alright, we're good though. Nothing broke, I don't think. Make sure that. I'm not very hopeful for this transistor anymore. I've been putting it through a test. Right. Come on, man. There we go. This is where we're going to make sure that it works first. I want to make sure that none of that stuff is touching. This coil is a little bit hard to work with, but we got this. All right, here we go. First step, making sure it works. Hello, hello. Five and a half volts in. I'd say that's pretty good. All right. And now, I'm gonna get my other multimeter. We're gonna see if we're charging right now. Well, the next couple minutes, seconds actually. Oh yeah, that's a depleted cap bank. Got 3 volts left in it. All right, let's turn on the power. So I think the transistor is only partially working. Yeah, we're charging, but it's not. It might be a bad transistor. Let me check this out. Alright, we're gonna have to work about the charging later. I think I blew my transistor and that's what the whole problem was. We'll see if I got one that'll work. There we go. Now this is me, like, oh, nope, that one's broken. Haha, dang, that one snapped. You can tell when they don't work or when they're broken. And that might be that. It's alright. It happens. I got some more coming in the mail on Tuesday though. Yay, we got one. Alright, let's try and get that cap bank up. I think it's because the cap bank is so low right now. It is charging. Huh. Yeah, I don't like it. I'm gonna wait for some transistors to come in to do any more with that. It might be the diode. Could very easily be the diode. So, see if I can't find one of those fast switching ones lying around. And this is what happened the first time I built the motor over there. I went to bed, I went to sleep, and it didn't work in the morning. I didn't touch anything, I didn't do anything. It just didn't work. And I was trying to figure out why. The batteries were dead. And I know they weren't dead when I went to sleep, so it's good to have a toggle switch on your batteries. Yeah, I think that diode is fried. I'm going to throw it away. Don't want to reuse these again. I could seriously damage some equipment doing that. Yeah, it's charging up a cat bank right now. Pretty steady charge. It's a tiny coil. It's only 200 turns, and it's 20 gauge and 28 gauge. And then the pickup coil's 30 gauge, or 32 gauge, my fault. And all that's hooked up to the cat bank. So this is 6 volts in. I'm trying to up the amount of voltage in the cat bank so that it'll speed up. Because there's a really heavy load on it right now because the cat bank's so low. Alright, all these magnets, let me get my meter. I've totally forgotten which way they're out. Oh man, where did I put that thing? Oh man. God, I just had it too. There it is. Yay! All north out. There's 5 magnets on the rotor. No, it's more like a Ferris wheel for magnets. But yes, it could be. This one over here that I have on the other table is more like a drone. See, because all you got to do is create an outer shell and put the magnets in the outer shell, and bingo, you got it. And you could have it all on the same shaft too. So you attach some blades, some propellers up to this thing, right? And then that's awesome. I mean, I really got to put some pressure on that thing to stop it. But if you can imagine for a second, since it's levitated, it's maglev. that you put these magnets in an outer ring, attach that ring to the shaft. You have like little spokes, like an Utron even, like this. Right? And you just attach the magnets to this part, and you have it floating above so it can spin freely. Attached to another one of these on the bottom, and you make it like a cage, and you put the magnets in the cage. Dude, there's your common rotator right there. That'll be fun. So let me do that so that people can kind of get a glimpse of it real quick. You get the bottom. Oh man, there's not a... Alright, so we'll use the pyramid instead. So this will go like this. Right? Now there's not going to be enough shaft to do this, but you kind of get the idea, right? Yeah, there is. Holy cow. Alright, so you link the top and the bottom together with spoked cage. You put the magnets, or you make the cage itself magnets. And then you make it so the rotor in the middle is maglev. Both to the ground and to the case. So it's floating there in the center. Wow, that's cool. Right now it's not floating there, it's kind of attached to everything, but it's just a general idea. You get it? Cool. Thanks for the likes, ladies and gentlemen. Should check out the generation going on over here. Woohoo! Things clipping at quite a pace. It's all coming from the transistor and the power supply to the right. Both through magnetic induction and throughput. Thank you. So you got your Bedini circuit throughput to the cap bank, and then you got your magnetic induction coil of the cap bank. So I have a drive coil and a pickup coil underneath. Wheel is spinning, sir. It's spinning. It's working too. I mean, it's like the throughput to the cap bank is pretty substantial. It's only 5.5 volts going in. .5 volts now. Right now, it's doing 770 milliamps. But you gotta understand, the coil I'm using is this big. And it's making things shake, dude. It's powerful. So we're down to 650 milliamps now. See, the more juice gets in the cap bank, the less milliamps get drawn. I don't think so, man. I'm pretty hungry. Yeah, I just set it up in the live. I just got done hooking it up. So you can watch back on this one. I have a few videos where I set up the SSG. That's what this is, a simplified schoolgirl circuit. Got a 100 ohm resistor on the trigger, and that's all the resistance though. I don't have a pot, so it's not Bedini because there's lots of things that I don't have that circuit does have. I don't have any added resistance on the drive. It's all on the trigger. Bang! Boom! No. No, not as of 3 years. I haven't had a boom in 3 years. When I was first playing with capacitors, I accidentally discharged a 400 volt capacitor without knowing I was doing it. Yeah. That'll wake you up in the morning. Like, pop! Oh yeah, it's real. I got 18 hamsters working really hard right now. I got 20 more hamsters on the way. We're about to up the torque. Because all the hamsters, they got the same leg length. So it doesn't matter how many you really put in there, it's not going to go much faster than a hamster can run. You know, that's its max speed. But you can put torque in there. You can put 100 hamsters in the wheel, and they will be able to hoist a sail. All right, this is a Bedini SSG, 100% grill. It's missing, it's Bedini S. Bedini S. It's missing a pot. It's missing a, that's it. Really. I just don't have a potentiometer in here. I tried putting one in. The drive coil is 200 turns of 20 gauge and 28 gauge. It weighs about 5 ounces. So we're drawing like 570 milliamps right now. But it's going down rather quickly. Went from 3 volts to 10 volts since I started running it. Alright, we're going to see if it goes up anymore. I've turned the power off. We got that induction coil though. We got that magnetic induction coil, the pickup coil. We're going to see if that spin is going to send us up or down. It's going down, so I don't know. Maybe it's not hooked up correctly. I think it is though. I think I got a bad connection on the cap bank. It's alright, man. This stuff, it's alligator clips. They're on the ground right now, some of them. I got a bridge rectifier, I mean, like, just chilling right there. But it's a big butt. This really does put a load on the rotor, like, really bad. See, because when it's spinning like that really fast, it should generate. I've seen it do it, and there's just something not right now. I don't know what it is. See, I think these little rectifiers get fried too easily. Yeah, I can kind of smell it. So we'll get it going a little bit. We'll get it going a little bit quicker, and then we'll turn it off, and we'll see if we're jetting like we should. The load isn't on there like it usually is. That's awesome. Damn it. I'm going to try a different clip. Yay! But you can see the load on there now. It was the clip. Man, I love it when I figure stuff like that out. That's great. Huh, did it just not work? Or what? Yeah, I don't know. Try 9 volts, we'll get it going. I have to switch out this other clip then too. pretty good. Huh. Cap bank's almost back up to full power. Oh, that looks good. Did I miss something? No. Hello, hello. Oh no. Man, I'm not trying to start a fire in my house. This is really simple. 9-volt battery right here. Probably for about 2 minutes, but then who's counting, right? All right, now I'm taking all the negative connections and I'm hooking them to one side of this diode. So I'm using that diode as a connection extender. Now I got 2 connections with 1 clip. What the hell? Wow. That was the positive connection. I hate it when I see sparks like that. I don't even know what the hell was going on there. Hmm. Yes. Yes. That's a great connection. I just spun the wheel and we got power in the cap bank. That's exactly what I'm looking for. No, it's not hot. It's from the wall. It's a power supply. The battery isn't even hooked up to anything right now. Oh wow, that is great power for the fact that that coil is actually generating electricity. It's only 200 turns, man. It's a tiny coil and it's making power. That's awesome. All right, let's get going a little bit faster. You can barely see how much I'm drawing. It's 9 volts, 600 milliamps. All right. It runs faster at 7 volts. And the amp draw drops 200 milliamps. So it's right in that sweet spot of 300, 350. Now if I could get one of my switches up in this thing, man, we could get some insane readings in efficiency. Some insane efficiency readings. It's just like that. This is it right here. The magnet catches the switch and it goes like that. It knocks on this copper. Boom, you get plasma. And you get great efficiency. Like great. I could go up to 75 volts and not even draw a milliamp. No. There's no heat here. Let me check the transistor real quick. Nah, it's not hot. Close. Now. Huh.
Hey, Dad. Oh.
Hi.
Hi.
Yeah, he needs clothes. Nah, it's not hot. I'm gonna try and get that coil up a little bit more. See if we can get some more induction off of it. Oh no, that's too high now. All right. So what I do want to do is I want to hook up this cap bank right here. I think this connection should work because it'll backtrack up to the end of this diode. So that's all connected right there. That's good. On the positive side. Yep. See these red lights? Or maybe you don't. I don't know. Let me look. But this cap bank is now full of energy. Now, what do? We disconnect the power supply and we hook up the other end of this cap bank with the same connections. So minus to minus, plus to plus. Let's start it up first. So now it's the cap bank. This is a Bedini SSG, so we got the SSG circuit right here, but what I'm doing with it is not Bedini. So right now we're running off the cap bank, we're charging the cap bank, and we're dumping the induction coil into the cap bank, and we're still spending way too much because of the coil. The coil's tiny. Coil's 20 gauge. It costs on the power supply like 800 milliamps to run it. So this is not the effective coil that you would use to get over unity or anything like that. This coil will not do that. As you can see, the cap bank is dwindling. The magnets are neodymium, and they're 40 millimeters by 20 millimeters. Square, so they're about this big, but they're square. You know what? I'm gonna let this run. It's gonna run into the ground, I'm pretty sure. But we're going to check this out over here. Yeah. Boom. So this motor is running on the same drive coil as that one is. There's one drive coil here, 20 and 28. It's a bifilar coil. This is running on a trigger strand. You got 3 30 gauge pickup coils that weigh exactly the same as the drive coil does, so it worked out just perfectly for balance and everything. Literally, that's 5 ounces of coil. There's 2,222 turns in the pickup coil, and there's 200 turns in the drive coil, and they weigh the same, and they take up the same amount of space. Perfect. I love it, man. And what's your point, Odin? That's cool. I can't wait to see if I can't turn this into a counter-rotating pulse motor. That would be sweet. But I don't think I have a 3D printer big enough right now that works to make the shell that I need to make. No, it's good. I'm not feeling any heat. I don't have a thermometer. I would love a thermometer that was free. I could really use a free one. None of this crap I gotta buy subscriptions for. But I don't care if it's good, man. If I need a script, it's retarded. I hope there's like, you know, an app or something that I can just hook into my phone for free to see the heat. Wow, it's still going down. We're at 6.81 on the cap bank. Wow. And then I got my little pyramid cap here. Styling headgear for the pulse motor. I love that. That's so cool. That turned out really well, the pyramid. Uh, 6:32, 31, 30. Yeah, it's depleting rather rapidly. But it is contained. The unit over on the other table here is contained within the cap bank, so it is charging and using the cap bank to run itself. Is it coming out on top? Absolutely not. That I didn't think it would. But it's fun anyway. Just to see how well that little tiny coil will do, you know? Because everybody's all like, you need 380 ohms in your coil, you need 4 inches for good inductance, you know, whatever. I don't know. Um, I've tried a lot of that stuff, and the tiny coils seem to have the biggest oomph in the most immediate way to present it. It's not really a generator coil. I see how the bigger ones would be good for quote unquote creating electricity. It's not really what's happening. You're just kind of spreading the butter over too much bread, is what's really going on. Saturation is the key to making all that stuff possible. See, because until you're saturated, the electricity will always take the path of least resistance. But when you saturate, all the paths get taken. So yeah, when you saturate, the path of least resistance gets taken first. But then when that's all full up to the point where it's backlogging, seriously, that's what saturation is all about. Um, It'll take all the other paths that are available. But to get to that point, I don't even know, man. I don't mess around with high voltage, at least not yet. And I know you need high voltage to do something like that. Oh, let's see here. See if we get any induction magic. We are. The cap, see when it's low, the cap bank is low, it goes up, and it goes up pretty quickly with the induction coil. So the lower it gets, I'm thinking the more effect the pickup coil is going to have. But of course, as the lower the voltage, slower everything just kind of catches up with itself, and it ends up dying. But it did go up 2 notches there. It's 4, nice. So what I could do is go take those off, go here, and here. Now that we got induction magic happening, we're going to do 2 things. We're going to charge the battery. We'll charge the battery and the cap bank. So, just real quick, we're going to hook up this other meter to the battery. No, it's not free electricity. It's electricity though. You know, it's debatable because people you know, they say it's free, and then there's an argument that nothing's for free, and then they say, well, that's not what we mean, and then it's like, okay, what did you mean? And then, you know, it's just a really bad word to say exponential gain. Really bad. Free is definitely not something that I would have chosen myself. I mean, I really enjoy doing this. It's I mean, I didn't always enjoy doing it. All right, let's turn this on. All right, so we're at 561 and 12.06. .07. We're already charging the battery. Yep, they're both going up. That's awesome. That is totally cool. I wish I knew how to play with zero energy, man, and I don't know. Maybe I am, maybe I'm not, I don't know. I've dabbled probably in a lot of things I didn't even know I was dabbling in. Everybody keeps talking about some sort of portal that I'm supposed to open up. I'm like, nah, man, I don't watch those kind of movies. But that the 0 point energy is actually pretty neat. So what we've done here is we've split up the two generating potentials of the motor. We got the induction coil going into the cap bank, and it's going up. And we've got the Bedini extension going into the battery, and that's going up. We are at 5.75 volts at 330 milliamps. So this one might not go up very much more, if at all. You got to put more voltage in to get more out. It's just a thing, man. It's totally a thing. The pickup, or the drive coil, the one that I'm using the Bedini for, is very small. It's 200 turns of 20 and 28 gauge, weighs about 5 ounces. But look at what it's doing. I got coils that are way bigger that don't do what this one's doing. They just don't do it. Like this one right here, 4 inches, 24 gauge, 32 gauge trigger. It will never go this fast. You can pot it, you can do whatever you want. It'll never do what this one's doing, but it will generate a lot more electricity. This will be going up a lot faster than it is. There it goes. Yay! Kinda yay. Yay! Alright, let me take you off the tripod. I'm going to show you around. It is... Okay, so there's our power supply. And like I said, 5.75 at 330. So we got the pickup coil and the drive coil both underneath the motor. They're both exactly the same size, they're just different gauges. We're charging a cap bank right here and a battery over here. This is the SSG, or a, as close as I could get. So you got your Zener diode right there. You got your neon light bulb down there as well. You got your Bedini extension, which is right here. This is charging the battery. And then it's all grounded appropriately and whatever. There's your connection to the cap bank, your connection to the battery. And let me think here. We're running off the oh no, right now we're running off the power supply. Yeah, that's right. We're charging both by running off the power supply. The magnets are neodymium, 40 by 20 millimeters. Here, I'll show you what they look like. I got a couple down here. These right here. Here's what's in there. About that thick. Could you imagine that axial flex rotor? Holy cow. So they're all neodymium. I mean, I have some ceramic, but I'm using the neos right now. No, it's a 5 magnet rotor, so I went all north. Yeah, if I did an 8 magnet rotor, I probably would have done north-south, north-south. But I opted for a 5 magnet rotor, and so they're all north. They are 1, 2, 3 spaces apart. So there's 2 spaces in between them, and then the third space is the magnet. That's all you can do with 8 inches, man. You have to work within your parameters, or just don't do it at all. And that's what I came up with, man. I'm like, I'm gonna do this. So 8 inches is as big as I can get. Here's my 3D printer. Or I would have made it 3 spaces for sure. Alright, so we're almost up to 6 volts on the cap bank. We were up to 12.11, it looked like, yeah. So these will take a while to charge up. I'm caught. Let me get on caught. There we go. Right. So I think this runs really smooth for only having 1 drive coil. It's amazing. So there's 3 pickup coils that are feeding the drive right now. think it might be knocking. I'm gonna find out. Let me think here. No, not really. Must have been something inside moving around. Haha. Mike! What's up, man? So it might be a little off balance when it gets going like that. It's even like bending a 10 millimeter shaft. But you know, since I have to, all that stuff can be worked out. But since I gotta hold it, it doesn't really matter how bad it is. Like I said, all that can be worked out, but as long as it doesn't like hurt me or hurt anybody else, I think it's a win. Alright, let's check how good we are over here. Almost to 6 volts. Same, pretty much. So let me get a meter reading on this. Got the styling headgear. With the tack strip on it. And then just for that little bit, up to 477, like in 3 seconds. Oh man. Haha. Ah, that's so funny. It is indeed a hat for the pulse motor. Styling headgear. Got a pyramid too. It's an exact pyramid. See, the height of the pyramid is exactly 1/2 the length of the base. Alright, I'm going to put you on a tripod. You got the wrong channel, buddy. What is Brownian motion? What is free energy? Thank you all. I really appreciate you coming out and hanging with me tonight. It's been awesome. I'm going to stick around for a little bit. Yeah, but it's on a shaft, buddy. If I had it like on wheels, and the shaft like sticking up from its motor base, from like its chassis, that would be sweet. Yes, I have. Thank you, John Gray. Yes, I have seen those. And yes, I do think it would be very useful to wrap one of these serpentine coils around like this hat, for example, and have it collect off these coils. That would be so cool. So yeah, that's something I might do. Yeah, there's a lot of force in this thing, man. It is amazing. You don't know until you actually have to put your hand in front of it to stop it. You don't know. It's awesome. I love it. I'm glad that it ended up working. This is like the 8th time I put this together. I started off with reed switches. Well, the first thing I did was the trigger coil, and it didn't work the first time because I didn't set it up easily like I did this time. I tried doing a Bedini SSG in there and it didn't work. It did not work. Oh man. But it's Bedini-esque, man. It's the 1, 2, 3 circuit, so you got your base, collector, and emitter with 1 connection, 2 connections, 3 connections respectively. And one of them is the light, and then the drive and the trigger, and that adds up to 1, 2, 3. You don't really want to put any more on there. I mean, I might do a Bedini connection just to see if it'll tip the balance. Who are you, Rick? Its function currently is to satisfy my curiosity. But you can hook up propeller blades to this and it'll fly. I'm thinking of a way already. I'm thinking of a way that I can make these magnets on a rotary as well and have it be a counter-rotating apparatus. All right, Denzel, I've had about enough of you. Who's NSA? McCall, who's the NSA? All right, since we've gone so far off topic, I think I'm going to call it for the day. I really appreciate everybody stopping by. Thanks for the likes. This is Papa Bale signing off. Peace out. Have a wonderful night. Bye now.